Welcome back to the OpenVINO channel. I have a model, it's trained and converged. Now, what is the performance? Intel has so many systems. Which system is good enough for me? Which system to use? Which device to use? And so on. The best practice is to know in advance what are your targets. This is usually derived from the overall application you're building and the product. It starts with frame per second, or actually inferences per second, as you might have many inferences in one frame. No need to shoot for 100 frames per second when your system needs only 10. Number 2, response time or latency. Some techniques like batching will improve the efficiency of your model but degrade the response time. If you're running a batch of 64 images at once, it might be more efficient per frame, but the first frame will take longer to infer. So, if you have a delay-sensitive application and you need real-time response, you might need batch of 1. 3. What is the best data format? Some devices support floating point 32 and integer, some floating point 16. Which format is best for my device? Number 4, which device? I have a heterogeneous system. I have a CPU, but also an integrated GPU and a Movidius VPU or an FPGA connected. Which device will run my model best? So the most simple way to do it is to use the benchmark app and try the same model on multiple devices or multiple systems. Let's open a directory for the samples. Initialize OpenVINO. CMake and make only the benchmark app. I'm showing the C++ sample, but there's also a Python application. Look for it. Now I need to create a folder with test images. You could use your specific dataset. I will only copy the car image from the security barrier demo. Now let's run the benchmark app. -I is the input images folder. -D can be any of the supported devices. Let's run it first on the CPU. -M is the model.xml, the IR file you generated using the model optimizer. I'll use a SqueezeNet model, and the model is running. You can see that the image is automatically resized to match the input size. You can see that the latency is 5 milliseconds and the throughput is 380 inferences per second. Now I can build a table to compare the inference efficiency and latency for various devices and configurations. Let's run with higher batch size. You can see that I'm getting disappointing results. So for this model, running with high batch on the CPU make no sense. Let's now run on the GPU. I'll need a floating point 16 format, and I'm getting 390 frames per second. Not bad. And on the GPU with batch 32, 710 frames per second. You can see that for my specific GPU, which has large memory, moving to batch 32 doubled the performance. And so on. I can run integer 8, different number of batches, and compare. Some other interesting flags. -API allow you to run the benchmark in asynchronous or synchronous mode. In asynchronous mode, the inference requests are being launched one after the other without waiting for the result, which will arrive when they finish the execution, asynchronously. -NI rec determines the number of infer requests launched in parallel. If you're using an Intel CPU, you can benefit from what we call throughput mode. This is a new feature from R5 2018, and it enables efficient parallel execution of multiple inference requests. It reuses the weights in convolution operations, which also happens in batching. But here the CPU cores are evenly distributed between the inference requests. The amount of scheduling and synchronization is reduced. The cache utilization is improved. And of course, we executed on multiple threads. So if you have a multi-core CPU, you can expect much better performance results. The rule of thumb is to infer up to the number of cores your CPU has. So I will run the same model, batch 1. I will ask for 4 parallel inference requests to be run on 4 threads. And you can see that we got to 404 frames per second. Of course, if you have a 28-core machine, you'll see here a huge improvement. If you'd like a detailed report of the execution, just add -- report type detailed counters. Once the benchmark is finished, all the data will be stored in a .csv file. You can open it and see the parameters, and you can find the execution time of each layer for each of the iterations. And of course, the summary at the bottom. So, if you have a model, use the benchmark app, use different devices, CPU, GPU, VPU, use different batch sizes, sync or async execution, different number of infer requests or threads, and so on, to find the best configuration that optimize your inference. Subscribe to our channel to get more videos like this. Thank you.